So now we move into the final section of this chapter where we'll cover lactation. Lactation is the synthesis and ejection of milk from the mammary glands. It lasts as little as a week in women who do not breastfeed their infants, but it can continue for many years as long as the breast is stimulated by a nursing infant or a mechanical device such as a breast pump. Women traditionally nurse their infants until a median age of about 2.8 years. Now, the high estrogen levels in pregnancy support development of the mammary gland by causing the ducts to grow and branch extensively. Under the influence of growth hormone, insulin, glucocorticoids, and prolactin, the breasts are able to develop and lactate. Progesterone is also involved in stimulating the budding and development of the acini at the ends of the ducts. The acini are organized into grape-like clusters or lobules within each breast lobe. Now, the first, quote, milk that a baby will receive is called colostrum, and this forms in late pregnancy. It's very similar to breast milk in protein and lactose content, but contains much less fat. The first 1 to 3 days after birth is when a baby will consume the colostrum. It's a little thin and watery in consistency and has a slightly cloudy yellow color. It contains lots of immune molecules, such as IgA, that protect the baby from gastroenteritis. It's basically putting the flora into the baby's digestive system. Now, milk synthesis is promoted by prolactin from the anterior pituitary. It's inhibited by dopamine when a woman's not pregnant. The synthesis of the hormone prolactin begins about 5 weeks into pregnancy. By full term, it's about 10 to 20 times the normal level. It has little effects on the mammary glands until after birth. At this time, it's the steroid hormones from the placenta that oppose prolactin up until birth. And so at birth, when the placenta is delivered, the steroid hormone component is removed and prolactin can support milk synthesis in the developed breast. As we saw, milk synthesis also requires growth hormone, cortisol, insulin, parathyroid hormone to mobilize the necessary amino acids for building of protein, and fatty acids and glucose, as well as calcium. At birth, prolactin secretion drops to non-pregnancy levels. But every time the infant nurses, prolactin levels surge again to the same levels that we saw at the end of pregnancy. This is to stimulate the production of more milk to replace the milk that the baby has consumed. If a mother chooses not to nurse, these prolactin spikes will cease and milk production will stop entirely within about 1 week. Now, breastfeeding will generally prevent a woman from becoming pregnant and thus acts to space out the production of offspring. Something about the prolactin secretions or a reflex from suckling on the nipple itself inhibits GnRH secretion, which reduces FSH and LH and thus inhibits ovarian cycling. Only about 5 to 10% of women do become pregnant while breastfeeding. But this is a fairly high percentage, so we can't count on it as a method of birth control. Milk is continually secreted into the mammary acini under the influence of prolactin, but it doesn't easily flow into the ducts and make its way to the nipple. So the milk ejection reflex is a neuroendocrine reflex, or the milk letdown reflex. The infant's suckling stimulates sensory receptors in the nipple, and this stimulates the hypothalamus and the posterior pituitary to release oxytocin. Remember, oxytocin is involved in most any event that involves contraction, involuntary contraction. Oxytocin stimulates the myoepithelial cells around each of the acini. They contract and squeeze milk into the duct. Milk will flow within about 30 to 60 seconds after suckling begins. This is the same stimulation that we're using with a breast pump. And there have been some rotten movies made about that. So breast milk changes composition over the first 2 weeks. It changes from the thin, milky, yellowy color to a more regular milk color. And it varies from one time of day to another. And it varies throughout the feeding. At the end of the feeding, for example, there's less lactose and protein, but 6 times as much fat. Now, cow's milk's not a good substitute for breast milk. It has 1/3 the amount of lactose and 3 times as much protein. The excess proteins form a harder curd in the infant's stomach, so it's not digested and absorbed as efficiently as mother's milk. It also increases the infant's nitrogenous waste excretion because of the higher protein content, which increases the severity of diaper rash, because the bacteria will break urea down to form ammonia, and ammonia is a skin irritant. Colostrum and milk also have a laxative effect. This clears the intestine of meconium, which is a substance that accumulates during later development. It's green and has a high bile content. Removal of the meconium will decrease the incidence of jaundice in babies. Also, breast milk is going to supply antibodies and again colonize the intestine with beneficial bacteria. Now, nursing women can produce about 1.5 liters of breast milk each day. Mothers with twins, they'll produce even more. Now, women are at much greater loss of bone loss when they're breastfeeding because much of the infant's skeleton is still cartilage at birth. And so it becomes mineralized at the expense of the mother's calcium and phosphate. So if the mother doesn't have enough vitamin D in her own diet, lactation will stimulate parathyroid hormone secretion, which activates osteoclasts, thus taking calcium from her bones to supply the baby with enough calcium and phosphate to mineralize its bone. So this completes our section on lactation, which brings us to the end of the chapter on the female reproductive system. Take a moment here to write down as much as you can remember about lactation, the hormones involved, the neuroendocrine reflex involved, and perhaps the differences between breast milk and cow's milk.